Hi class, here's our video lesson on 12.4. We're going to discover the formula for the surface area of cylinders today, and then we're going to solve a variety of problems involving the surface area of cylinders. So here again, here's what a cylinder looks like. A cylinder has two circular bases, and that's what this first arrow is pointing at right here. It's pointing at the bases of these two cylinders. This cylinder to the left is called a right cylinder. The reason why it's called a right cylinder is because the bases and the lateral faces are perpendicular, whereas this is a little more of a slanted one. We call that oblique. This one is an oblique cylinder. We see right cylinders more oftentimes in the real world, but we'll deal with both right cylinders and oblique cylinders in this chapter. So now what this arrow is pointing to right here is the distance from the center of one base to the center of the other base. From the center of one base to the center of the other base. This is called the axes of the cylinder. And then this last arrow is pointing to the perpendicular distance between the two bases. So you can see this 90-degree angle right here, this perpendicular distance between the two bases. And this is called our height. Remember, the base and the height are always perpendicular. Sometimes we also call this the altitude of the cylinder, altitude. Notice in a right cylinder, the axes and the height is the exact same distance. But in an oblique cylinder, the height, the perpendicular distance, is shorter than the axes. The axes is like the hypotenuse of the right triangle here. So be aware of that as we go through this unit. All right, what we're going to do now here is we're going to draw the net of a right cylinder. Before we draw the net, let's just watch a short video just so you can kind of get a perspective about what the net looks like. So we have two circles. A cylinder has two circular bases, and then it has a rectangle in the middle. The rectangle is what happens when you unfold the lateral area there. So you can kind of see this cylinder. And then if you fold back the two circles and kind of peel back the lateral area, you see that rectangle in the middle. So notice the height of the rectangle is the same as the height of the cylinder. If we were to find the area of the rectangle, it would be base times height. We got two circles, and the area of those two circles are pi r squared. So now notice something very significant. The base of the rectangle, where those two arrows, white arrows are pointing at, that is the same as the circumference of the two circles. Can you kind of see that? So that's what we want to draw here for our net. So if you could maybe draw something like this on your notes. We have a rectangle in the middle, and then we have two circular bases, right here and right here. So that's kind of what the net of a right cylinder looks like. So if we now want to find the surface area, the two circles right here, we said are pi r squared. Pi r squared. And those two circles will always be congruent. So the surface area is going to be the area of all of the surfaces. So if there are two circles, then we're going to say it is 2 pi r squared. Now we also have to add up this rectangle. And this rectangle, we said that it's base times height, and the height of the rectangle is the same as the height of the cylinder. And the base of the rectangle, this distance right here, is the circumference of the circle. And circumference equals 2 pi r. So if we do base times height, 2 pi r times h, it would be 2 pi r h. Everybody, this is the surface area for any cylinder. It's all the areas of all the surfaces added up together. There's two circles, so it's 2 pi r squared, plus the lateral area is 2 pi r h. So speaking of the lateral area, it's also beneficial to talk about the lateral area. It's the same as the formula for the surface area, except it's not the two bases. So we aren't going to add this 2 pi r squared. So the lateral area is just the area around the outside without the two bases, just the 2 pi r h. And that is our lateral area. Okay? All right, let's solve a few problems now. You want to cover an ice cream bucket with paper. It is 10 inches tall and has a radius of 7 inches. How much paper will you need? Well, this one I give you everything that you need. The surface area of any cylinder is 2 pi r squared plus 2 pi r h. So it tells us that the radius is 7. So surface area equals 2 pi 7 squared plus 2 pi 7 multiplied by the height, and the height is 10 inches tall. Whoopsies. 10 inches tall. All right, let's answer in two different ways. Let's have our exact answer in terms of pi, and then we'll also have an approximate answer. Here we go. 7 squared is 49. 49 times 2 is 98 times pi. 98 pi plus 7 times 10 is 70 times 2 is 140 pi. 140 times pi. If you add up 98 pi plus 140 pi, you get 238 pi. 238 pi, and our units are inches. Inches squared. So this is the exact answer for surface area. If we want to approximate, we'd multiply that by approximately 3.14. And if you do that, you would get 747.7. 747.7 inches squared, or square inches. So that's how many of these would fit all the way around the cylinder, and on the bottom base, and on the top base. There's 747 square inches. Next to, I give you the surface area, and you have to find something else. So here I give you the surface area is 122.5 pi. I want you to find the height when I give you the radius. I give you the diameter, but of course you could find the radius of that, right? It's half of the diameter, so the radius is 2.5. So here we go. The surface area of any cylinder is 2 pi r squared plus 2 pi r h. Isn't it wonderful? Because it's two circles, and it's one rectangle around the middle. Woo! The surface area we have of 122.5 pi. That equals 2 pi. We have the radius. The radius is 2.5 squared plus 2 pi. We have the radius of 2.5. We want to find the height. All right. One thing that's kind of nice, class, there's 3 different terms in this formula. Here's one term. Here's 2 terms. Here's 3 terms. If they all have the same factor, we can divide by that factor, and it doesn't change the equation. They all have pi. So if I divide by pi here, and I divide by pi here, and I divide by pi here, it's gone. And doesn't it make life easier? Yes, it does. So now all we have on the left side of the equal sign is 122.5. That equals, if you square 2.5 and then multiply it by 2, so it's 2.5 times 2.5 times 2, you get the number 12.5 or 12.5 plus, and then 2 times 2.5 is 5 times h is 5h. So 122.5 equals 12.5 plus 5h. So let's solve for h. Subtract 12.5 from both sides. And then you would get 110 equals 5h. Divide both sides by 5. And h, the height of our cylinder, is 22 centimeters. 22 centimeters. And our last one for the day, this time I give you the height, but I do not give you the radius. So once again, if we write down the surface area of any cylinder is 2 pi r squared plus 2 pi r h. This pi symbol was crazy. Here we go. 2 pi r h. I give you the surface area. I give you the height, but we need to find the radius. Okay, so it's done a similar way, just one notch of higher in difficulty level than the last one. So 528 pi, that equals 2 pi radius squared plus 2 pi radius times 10. Once again, I have three different terms, and they all have pi in them. So I'm going to divide by pi, I'm going to divide by pi, and I'm going to divide by pi, and my life is now at least easier. So 528, that equals 2r squared plus 20r. Well, like I said, I have three different terms, and if they all have the same factor, I can divide by that factor, and it doesn't change the equation. Three different terms, and they are all divisible by 2. So let's divide 2 by each and every term as well. 528 divided by 2 is 264. That equals 2 divided by 2 is 1r squared, plus 20 divided by 2 is 10r. So now, class, I still have three different terms. One is called a constant term, one is a r squared term, and one is an r term. When there are three different terms, everybody, in order to solve, we need to put it into our standard form of a quadratic equation. So ax squared plus bx plus c equals 0. Let's get a 0 to one side of the equation. And the easiest way would be to subtract 264 to get a 0 on the left side. So a 0 equals, in descending order, r squared plus 10r minus 264. So what I always kind of tell people is that once you have three terms, you factor it or use the quadratic formula. If you have three different terms, you got to think factor or quadratic formula. We could factor this one, everybody, but it's kind of difficult to factor 264. So let's actually do the quadratic formula on this one. And I have that on the next slide for your reference. A negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's practice this one so we could all be familiar with how to do this if you ever need to do it on your own. So a is the number in front of our r squared term. So there is 1r squared. B is the value in front of our r term, and that value is 10. And c is our constant term. It's a negative 264. So our answer comes from a negative b, a negative 10, plus or minus the square root of b squared. A negative 10 squared is a positive 100. Minus 4 times a, which is 1, times c, which is negative 264, all over 2 times a, and 2 times 1 is 2. So now we're going to slowly solve or simplify this radical. Negative 4 times 1 times a negative 264 is what we're going to do first. And that becomes a positive 1056. So we still have the negative 10 plus or minus the square root of 100. And then this right here, a negative 4 times 1 times negative 264 becomes a positive 1056. All of that is divided by 2. Now if we add 100 plus 1056, we get 1156. So negative 10 plus or minus the square root of 1156 divided by 2. We put the square root of 1156 in our calculator, and we get 34. The square root of 1156 is 34. So now we have a negative 10 plus or minus 34 divided by 2. So we're going to get two different answers for our radius, a negative 10 plus 34 divided by 2, and a negative 10 minus 34 divided by 2. A negative 10 plus 34 is 24 divided by 2. Our radius equals 12. A negative 10 minus 34 is a negative 44 divided by 2. Our radius equals a negative 22. Does it make sense for our radius to equal a negative distance? The answer is no. This one doesn't make sense. We call that an extraneous solution. So our answer is 12 and 12 what? The height is 10 inches. The surface area is 528 pi square inches. So our radius is 12 inches. Again, we could have factored this, and when you factor it, you would have gotten r times r is r squared minus 12 and plus 22 to equal 0. So then you would have gotten r equals a positive 12 and r equals a negative 22. So that's also a possibility if you feel more comfortable with that, or you could use the quadratic formula just as we did. Let me know if you have any questions on cylinders when you get to class.